Hello, everyone, and welcome to Cognify. So, in today's video, we'll be tackling a bit of number patterns. Okay. So, in this question here, we are given dark tiles, right, and light tiles. So these are used to create patterns on the floor. The first four patterns are shown below. Okay, so we've got pattern 1, 2, 3, and 4. So for the patterns that follow, the tiles are arranged in a similar manner. So the expectation here is that these patterns follow a particular pattern. Okay, hence why this is number patterns. So the expectation here is that we should be able to derive some kind of formula that we can use to find a number of tiles on pattern 50, 100, etc. But let's tackle each of these questions and see how we go about resolving them. So for the first question we are required to find how many dark tiles were used in pattern 5. So let's see, we've got 3.1, right? So let's try and see something here. Let's break this up. Okay, for now we are focusing on dark patterns. Let's count how many dark patterns there are. Okay, so in pattern 1, this one here, how many dark patterns? There's one. So we'll say 1D. Okay, one dark. Next one, in pattern 2, we've got 3. So 3 dark patterns. And then the next pattern, we have about 1, 2, 3, 4, 5. So 5 patterns. So we can already see there is a pattern here, right? So the last one is 1, 2, 3, 4, 5, 6, 7. So you simply count them, 70. So we notice here, if we look at consecutive terms, there is a constant difference of 2. Okay, 2D, 2D, 2D. So in this question here, we want to find how many dark tiles were used in pattern 5. Okay, so what we have here, this one is the first pattern, second, third, fourth, and then there's fifth and sixth. Okay, so for the fifth pattern, we expect there to be 9 dark tiles. Okay, so for this one here, we have 9 dark tiles. And we can be certain of this because we are implementing a rule here, right? For each term in the sequence, we are incrementing it by 2. Now let's go to the next one. In the next question, we now want to find the number of light tiles. Okay, so if we go to our number pattern here, right? Let us check. Our first, in pattern 1, we've got 0 white tiles. So we'll just put 0. And then in the second one, we've got 1. And then in the third one, we've got about 5. Let's confirm 1, 2, 3, 4. Actually, 4. And then next one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 white tile. And this is the first term. This is the second pattern, third pattern, fourth. And for this example here, we want to find the sixth, right? So we'll have 5 and 6 pattern. So now if we compare this number pattern, right, to the previous one we were just working with, you'll notice that it's a bit different. Why? Because if we were to find the difference here, the first difference, right? So this is called the first difference. First difference. Okay. We see here that we have one difference here between the first and second pattern, and then between the second and third, the difference is 3, and then difference between third and fourth, we see it's 5. So the difference here is not constant. Okay, so we cannot apply the same logic we applied with the previous one. So now let us take it a step further and find the second difference and see if we can find some kind of pattern. Okay. So now if we find the second difference, what you will notice is that it's actually constant. Okay. So now this gives us a clue already that we're dealing with a different type of number pattern. The first one that we're dealing with, right? It's linear because there is one constant difference. Okay. With the second one, it would have to be quadratic. Okay. Because the first difference is not constant, but the second difference is. So now we want to find the sixth term, right? So let us quickly see here. Let's check here, right? So if we were to find, let's see, difference between fourth and fifth and difference between five and six. What we know here is that these differences at this level here, right, is 2W. So we can just increment it by 2W. So what we do is we take this here, right, and then we add it to that. When we add it, what do we get? We get 7W. So now from here, what you will notice here is we can then take this and then add it to that 7W. So we are just going in the reverse, right? So now 9W plus 7W is 16W. And now we do the same here as well. The difference here, it has to be 2. So 7 plus 2, okay? And you're going to do the same here as well. So 7 plus 2 is 9W. Then 16W plus 9 is 25. So the sixth pattern, right, has about 25 white tiles. And that is basically it, okay? Now let's go to the next question. So next question is 3.3. So now in 3.3, let's maybe just move this to the right. Okay, so now in 3.3, we want to write down the general term for the number of dark blocks used in each pattern. Okay, so let us see here, right? So in 3.3, we want to find the general formula, okay, dn. Why? Because if you want to find, let's say, the 1000th pattern, right? We want to find the number of dark tiles for that pattern. We don't want to be incrementing each and every term to get to that point. So instead of taking that long step process, right, we can simply use a general formula where we simply input a value and then get the required output. So the general formula you use to derive it, right, is as follows. So it's going to be A, which is your first term, plus n minus 1 multiplied by the difference. Okay, so if we go back here, right, just to look at what our values are, our first term, right, in our sequence here is 1D. Okay, so we can substitute that. We can just put it as 1 for now. Okay, you don't have to say 1D. And then plus n minus 1. N simply represents the nth term. For example, you want to find the fifth term, the 10th term, okay? 10th pattern, 15th pattern, etc. And then we have the difference. The difference is what we got here, right? Which is 2. So now if we simplify this, what do we get? 2n minus 2, and this is equal to 2n minus 1. So this is the general formula, right? But before we conclude with it, let us test it out. Let's say we want to find the number of dark patterns, right? On the fifth pattern. So now we do it like this, right? D5. Okay, this subscript 5 denotes the fifth pattern is equal to 2. multiplied by 5. Okay. So this here and this here go end in end. Okay. Multiplied by 5 minus 1. So here we get 10 minus 1. And the answer is 9. So we have 9 dark tiles, which coincides with this here. So this confirms that our equation or formula is correct. So now let's go to the next part. So in the next part, right, we want to now find the general term for the number of light tiles used in each pattern. So for this one, we're going to take a different approach because we're dealing with a different type of number sequence. Okay. So for quadratic number pattern, this is how you go about doing it, right? Firstly, you'll use this approach, right? You're going to take 2a and then equate it to your second difference. Okay. So the second difference here is 2. So now our a is equal to 1. Okay. And then the next step, you then take 3a plus b and then you equate that to the first term of your first difference, which is 1. You see, we are going in this direction here. We firstly dealt with that. Now we're dealing with that. Okay. 3a plus b. And that is equal to 1. Okay. A, we got it from our previous calculation here, right? So it's going to be 1 plus b, and that is equal to 1. So b is equal to minus 2. Okay. So the goal here is to find all the constants that make up a quadratic formula, right? But before we commence, for those that are not familiar, the general formula, right, is written as this: a n squared plus b n plus c. Okay, so we already found a, we found b, lastly we need to find c. So for c, we'll take a plus b plus c and then equate it to the first term of our series number pattern, okay, which is 0. So it's the same approach here, right? We're going from bottom to top. Firstly, we equated 2a to that, and then 3a plus b to that, and now a plus b plus c to that. So we'll put a 0 there. So a is 1, b is minus 2, and c is what we want to find. So now c is equal to 1. So now if we substitute it into here, what do we get? So we're representing this as ln is equal to 1 times n squared plus minus 2 times n plus 1. So this is equal to n squared minus 2n plus 1. And that is basically the formula. But before we conclude, it's better to test it out, right? Let's check it out with this one here that we had derived, the sixth pattern. So for the sixth pattern, we expect to find 25 white, okay, tiles. So now let's see that. So L6 is equal to 6 squared minus 2 times 6 plus 1. So this is equal to 36 minus 12 plus 1. Okay, and this is equal to 25. And that is basically it. So finding general formulas, they actually make these calculations simpler, because with the general formula you can literally find the number of tiles for any pattern, whether it's 1,000, 100,000, etc. Okay then. So now let's go to the next bit, right? So in question 3.5, we now want to find which pattern will have exactly 64 light floors. So our formula, right, is defined as ln is equal to n squared minus 2n plus 1. This is the formula, right? So now we want to find which pattern. Is it the 10th pattern, the 15th pattern, the 20th pattern? Previously, when we're using these formulas, we were simply substituting n, right? But what does n represent? It's the mm, pattern, okay? Is it pattern 5, pattern 10, etc.? So here we'll be solving for n, okay? We are given that there are 64 light tiles. So we can substitute that in ln's place. So we'll have 64 is equal to n squared minus 2n plus 1. So this would be n squared minus 2n plus 1 minus 64 is equal to 0. So this will be n squared minus 2n minus 63 is equal to 0. So now what we need to do here is find factors, right? And factorize it. So you can take this quick approach, put the coefficients in front of n squared and this constant u. Okay, break it up. 1, break it up into 1 and 163. We look at this middle coefficient here, we'll see it's a minus 2. So what factors, right? Because we see here we've got 1 and 1. Okay, so this here needs to be 9 and 7. Why? Because when you cross multiply these here, okay, when you add them up by first assigning a negative to the 9 and a positive to a 7, you get a negative 2. So now those are our factors, right? It's x minus 7 and x plus 7. So now x, it's not supposed to be in terms of x, but in terms of n. So we'll have n and n. Therefore, n is equal to 9 or n is equal to minus 7. We have to discard that because for our case, use case, right, we cannot consider negative numbers of n. Why? Because there's no negative 1 pattern, negative 7 pattern. So this is the one. So we can confirm this by substituting into ln, but I'll leave that to you guys. Let's now go to the last bit, okay? So in the last bit, let us do it copy. So for the last bit, 3.6. For this part here, right, we are given that each dark tile is 0.3 meters wide and 0.6 meters long. So let's just quickly draw something here. Okay, so we'll have this tile, okay, so 0.6 meters long and 0.3 meters here. Okay, okay, then so that's one tile, right? So now we want to calculate the total area covered by all dark tiles in the first 100 patterns. Okay, so now what we need to do here is to refer back to the formula that we derived, which is this one here. Let's take that, right? So we have d n is equal to 2n minus 1. So now here it says you want to find the area covered by all dark tiles in the first 100 patterns. So now we need to find how many dark tiles are there for the first 100 patterns. So we can use this formula to find the number of dark tiles, right? So this will be 2 times 100 minus 1. Okay, so this will be 199. So there are 199 dark tiles, right? So now we need to find the area of all these dark tiles. So here we've drawn one dark tile. Okay, so when you want to find an area, we know that area, okay, we need two dimensions. In this case here, we can use length and width. Okay, so we'll have this length and this length here. So that would be the length and that would be the width. So we need to multiply this and get an answer, right? If we do it for one tile, okay, this will be 0.3 times 0.6 and then we'll get an answer. But we want to do this for 199 tiles. So now if we expand on this, right, let's draw another tile here. We'll just draw two more tiles and they are the same dimensions, right? So this would be 0.6, this would be 0.6. What you'll notice here, right, is we can take either of two approaches. We can draw the tiles like this horizontally, or you can stack them up like this. But it's the same thing because at the end you're multiplying the same dimensions. So now this will be dark tile 1, dark tile 2, dark tile 3. We want to do this for all 199. Okay. So now what we need to do is find the total length across this whole horizontal line here, right? Where we stack up all these dark tiles. So we know about 199, right? That we're going to be stacking at 1, 2, 3, 4, etc. Now we can multiply that by 0.6, okay, to find the length, okay, across that direction. So let us quickly calculate this, right? So now 199 multiplied by 0.6, that is equal to about 119.4. 119.4 meters. Okay. So that is like the total length. So I'll just put this as LT. Next is the width or the height. You can just call it height. Okay. This is the height. For area, we just need two dimensions. So the height here is constant, right? We're not really changing it. So we keep it at 0.3 meters because all of these are stacked horizontally. Okay. So now all we need to do is take these two and multiply them.